Hello everyone. Today we are going over a Spring 2025 Midterm 1 problem. This problem focuses on the topic of boundary conditions. We are given a set of parameters in this problem to find the B field or magnetic field in another medium. So first off, what is given in this problem? We can see through right-hand rule that the z-axis is out of the page. There are two mediums. One is air with a permeability of 1 mu naught, and another medium, a block, with a permeability of 3 mu naught. There's a B field in air given as 2x hat minus 4y hat minus 3z hat, and the block is also angled at 37 degrees above the x-axis. And lastly, there's a surface current density, Js, along the inclined plane. So, what equations can be used? These following equations can be used. N hat crossed with T1 hat equals T2 hat. B equals H times mu, or H times mu r times mu naught. B1n equals B2n. And n hat crossed with the vector of h1 minus the vector of h2 equals the vector of the surface current density, Js. So how can you start this problem? With this boundary condition problem, I would use coordinates of n, t1, and t2 instead of the xyz coordinates. Converting into a coordinate system of n, t1, t2 can be applied easier into boundary condition equations. For example, when n hat is found, both b1n and b2n can be found using the equation b1n equals b2n. However, one thing to note is that when changing coordinates, they must obey the right-hand rule, just like the Cartesian coordinates. That is why n hat crossed with t1 hat equals t2 hat. With this understood, it is possible to find n hat. N hat is a normal vector perpendicular to the surface of the block. We can find the xyz components of this normal vector with the 37 degrees. We know that there is a right angle between the x and y axis. Therefore, the angle between the block and the y-axis is 90 minus 37, which is 53 degrees. Since the normal vector is perpendicular to the block, there's another right angle between the vector and the block. Therefore, 90 minus 53 is 37, which is equivalent to the inclined angle of the block. When broken down into components, it is shown that n hat is negative 3/5, 4/5, and 0. To find B1, the dot product of B1 and n hat is used. It is needed to do this because the dot product shows how much length of B1 has in the n hat direction. This dot product is also used for T1 hat and T2 hat. With this, we get negative 22 over 5 as B1n. Next is to find T1 hat and T2 hat. Both of these vectors are tangent vectors to the plane. Therefore, T1 can be found going down the inclined plane. The angle between the T1 hat and the block is equivalent to the 37 degrees. Therefore, when broken down into components, T1 hat is negative 4/5, negative 3/5, and 0. When n hat and t1 hat are going in their respective directions, through right-hand rule, t hat is going in the positive z direction, or out of the page. Therefore, t2 is 0, 0, 1. With these, we can use the dot product to find B1 T1 and B1 T2. B1 T1 is found dotting B1 dot with T1. And B1 T2 is found with B1 dotting with T2. With this, we get the value of B1 T2 equaling -3 and B1 T1 equaling +4/5. With this, B1 is converted into -22/5 n hat plus 4/5 T1 hat and -3 T2 hat. Next is to apply the boundary condition rules to find B2. So we know that B1n equals B2n. Therefore, B2 has an n component of -22/5. However, we don't know the other two components, T1 and T2. This is where the other two equations come into play to find the rest of B2. The equation B equals H mu R mu naught defines a magnetic field where B accounts for the permeability or magnetic property, whereas H doesn't. With this equation, H equals B over mu R mu naught. We can plug in B1 and B2 to find the vector of H1 and the vector of H2. With this, we found the vector of H1 being -22/5 mu naught, 4/5 mu naught, and -3 over mu naught. The vector of H2 is found as -22/15 mu naught, B2 T1 over 3 mu naught, and B2 T2 over 3 mu naught. After this, it is possible to use the last boundary condition equation needed for this problem. This equation is the n hat crossed with the vector of H1 minus the vector of H2, which equals the vector of JS. With this cross product, we write n hat as 1, 0, 0. We do this because we converted from XYZ to NT1, T2. So the unit vector of n can be written as 1, 0, 0. Similarly, the unit vector of n can be written as 0, 1, 0. In this cross product is also equal to the vector of JS, which is 0, 5 over mu naught, and 0. But why this? We do this because from the figure above, it is shown that JS is going along the inclined plane, but in the T1 direction as well. If T1 was defined in a different direction, a negative must be introduced in the surface current density vector, and the direction of T2 will also change as well. Solving this cross product, we get the following: 0 n hat minus 3 over mu naught minus b2 t2 over 3 mu naught plus 4 minus 4 over 5 mu naught minus b2 t1 over 3 mu naught. With this, we could see that we get two equations. We get 3 over mu naught plus b2 t2 over 3 mu naught equals 5 mu naught, and 4 over 5 mu naught minus b2 t1 over 3 mu naught, which equals 0. On the first equation, we could see that we could cancel out all the mu naughts, and then we could move 3 to the other side, and then we can multiply it by 3 and get b2 t2, which equals 6. On the second problem, we can move b2 t1 over 3 mu naught on the other side and cancel out the mu naughts, and then we get b2 t1 as 12 over 5. With this, we get b2 as negative 22 over 5 n hat plus 12 over 5 t1 hat and plus 6 t2 hat. However, it is needed to convert back into the x, y, z coordinates. With the equation written, we can see that to convert back, we must plug in the n hat, t1 hat, and t2 hat vectors we found. With this, we get positive 66 over 25 x hat, negative 88 over 25 y hat, plus 0 z hat, and then minus 48 over 25 x hat, minus 36 over 25 y hat, plus 0 z hat, and then for the last one we get 0 x hat, 0 y hat, plus 6 z hat. And then adding them all together, we get the final answer of 18 over 25 x hat minus 124 over 25 y hat plus 6 z hat. And that is our final answer. And thank you for watching.